So this is where we are at from the last time. So in the last session, we learned few new things. You're able to see my screen, right?
Yes, sir.
Cool. So yeah, in the last session, we learned a few new things about prefabs and how to instantiate prefabs and basically how to move between scenes and how to store data between scenes using player prefs. So these are some of the things that we learned that were new. So from and there was one topic, procedural generation, which we left in the last session. That is what we'll discuss today. So today we are going to discuss procedural generation, and we'll start on a new game. Like randomly just calling this game Color Runner. So this is a game where you can see the rules. Basically, you are a player. You're controlling a ball as a player. That ball has some color, and you have some boxes coming towards you, and you can basically to score higher. You basically click on or go through the box that is of the same color as you are, and we can, as you can see, the scene in this environment is a bit beautiful. You can see some clouds and stuff, and like we'll talk about how to make it a little bit beautiful. Like we are still working with primitive shapes and primitive environment till now, and we'll continue to do that because that's easy to learn and prototype, and it's faster that way if you're learning that way. So yeah, so talking about rules of this game that we'll build, basically we have that the player can only move left to right, either in this direction or in the right direction. And whenever there's a collision with one of the objects that is coming towards the player, and if the color is same, like basically that is when we check if the collision happens. That is when we check the color of the player and the object that it is colliding with. If the color is same, then we increment the score and we change the color of the player. Randomize again, change the color of the player. And if the color is not same, then game over, which is not recorded in this, but yeah. That and in this game, we'll also learn how to use some of the assets that Unity has given us, some free assets initially. Like you can see the clouds and stuff. That is something called as skybox. We'll learn about that. We'll learn about importing assets. We'll finally see how to import assets and how to use them. One more thing that we'll do in this game is to build for mobile phones. So I'll build for Android because I have that. If anyone has an iOS or wants to try for that, then they can try for that as well. But the process for building for iOS is a bit different. But I'll share those videos with you. So basically, in iOS, there's a process that there's a extra step. So for Android, basically you build right out of Unity, but for iOS, you'll have to go through an Xcode editor. So you can basically to install it on your phone, can't go directly through Unity. As far as I know, the last time I checked, if anything has changed, I'm not sure, but I'll look into that. And for people who want to do specifically that iOS builds, I'll share the appropriate resources according to that. So yeah, so today's session we'll start with procedural generation only. Uh, Last time we touched upon it. So like basically, let's see what Google says about procedural generation. Oh, sorry. So basically, procedural generation is two big words for one simple thing. That's the creation of data by computers. So procedural generation is usually used to create content for video games or animated movies, such as landscapes, 3D objects, character designs, animations, or non-player character dialogue. So basically, like we discussed last time as well, anything in a game or anything in a simulation that is generated algorithmically, like you're not doing it manually, can be termed as procedural generation. So the thing that we did by instantiating prefabs, the collectibles that we instantiate, technically that comes under procedural generation. So we look at a very small concept of procedural generation today. That concept would be of creating an endless platformer. So like you've seen games like so the one that we are creating in the next color runner kind of thing, that's also like an endless platformer in a sense that uh, the objects keep coming towards you until you end the game. So that is like we'll look at how that is done, but first we'll look at how we can use procedural generation. Like we can write some codes to basically create a system where based on like some specific conditions, you can create more of the world that you are living in a sense, right? So basically what we'll try to do is basically uh, like rollerball, we will have a player rolling upon a plane, which was the ground. And when the player reaches the edge of the ground, we'll create more ground for it. Basically, we'll create an never-ending world in a sense. So we'll see that is one of the most simplest things that you can do in procedural generation. And there's a lot of complex things that you can do with procedural generation, like it's mentioned here, like creating landscapes. So recently, a lot of new companies are basically doing this, and a lot of assets are available on Unity Store as well. And we look at that, which basically on a click of a button, you can create 3D environments of whole cities, whole forests, like depending upon whatever you want, you can create those big scenes. So there's basically a set of specific algorithms, set of specific rules and instructions that go in the background. And on top of that, these things are built. So like if I want to build a city, I can write an algorithm where first the very roads are generated, some network of roads are generated, then some buildings are generated on the sides of the roads, then some lighting is generated, some uh, non-playing characters, some random walking players are generated. So things like that. So like I can write all these and basically make it dynamic, make it random, make things random. So like every click of a button will create a new world. So that basically gives us more power to create faster. And but that is not always the best way to do things. Like if you see some of the very big games, they have a very specific map. They don't have randomized maps every time you open it, right? So that is also one way to. So when we create a very big world and we want the player to keep coming back to it, we want the player or the user to basically engage the user, and you want the player to learn that area. Then you basically would create a specific map so that the player learns different parts of that area, keeps coming back to it, explores that specific area, and things like that. But when you have a small game, games like which we generally call casual games, or now they're hyper casual games, there you want a lot of random uh, things happening in your environment. So, like let's say Temple Run, games like Temple Run or Subway Surfer. So, like the turns that are there in those games, the trains that come in Subway Surfer, or the turns that are there in Temple Run, or the walls that are breaking, so you have to shift to one side, things like that. If you played these games, you'll know that these are not fixed, these are randomized, right? So that is the difference between how you engage the players in different genres. So games like PUBG or Fortnite, they're played on a specific map. So that's why players keep coming back to those, explore different areas. They know the name of areas by name. But in games like Temple Run, Subway Surfer, there basically you generate the map as the player is playing. Generate the directions, generate the obstacles. It's not fixed. it's being generated by some algorithm. It's not manually done. So that is the difference between procedural generation and doing things manually. Cool. So let's try to do what we want to do in this project only for now, and then we'll create a new project for the other game. So in our scenes, let's create a new scene. Let's call it procedural gen. Doesn't matter much actually, but still. Uh, so in this, what we want to do is basically just create a plane and start with this and zero it out first. Right, and we had some prefabs here, I think. Oh, sorry, materials for the ground. We can give it that. We can call it ground. So these are just good practices, even if you're prototyping, even if you're like want to test something small and just be quick about it. Still, the best way to go about it is to keep doing the naming practices, keep adding the materials that you have decided, like still make it look a bit better than general, whatever it generally looks like, and keep the naming nomenclature, whatever you decided for your games, whatever you've decided in your general perception. So do keep doing that, keep maintaining it basically. And then let's make this a bit bigger, 2 x 2 maybe, right? And that's it. That's our ground. And let's create a flare. So flare would be a sphere, and flare would be, so we can use some of the scripts that we've already created in Rollerball to basically move the player around and stuff like that. So there and 5. I hope you remember all these things, why we are doing these small things. And let's move the player back a bit. This is where we'll start from. And move our camera a bit up so that we'll be able to see what is happening. So rotate it a bit. Since it's fine. Cool. So now we'll write a few scripts to basically make the ground, like we can, like let's first write the player. We already have the script, player controller. Let's just put it here. We don't need these things. So in our player controller script, in our, no. So we can basically, so that those things don't cause us errors, we can remove these things, comment them because we are using them somewhere else, and comment this. Whatever things are not required, you can just comment it out for now, just to make it easy. Bring back. So fine, we can make this 5 or something. And I think we need to add a rigid body. Yeah, that's all. I think we'll be able to move now. So that's also what we'll do now is once the player reaches this area, right, this around this area, another plane gets added in front of this plane. And this keeps on happening as we go forward. So we can also maybe attach the camera controller. I think this would be fine as is, and just add the player. Does this work? Yeah, but the camera is not positioned properly according to the player. I guess this is fine. This way we'll be able to see what we are actually doing. And next, let's create a few scripts. So one script would be ground spawner. So in this, what we want to do is basically have a public game object for our ground. So public game object instead of spawner, let's call it ground. We'll have a function which will be called on some event. We'll look at that event also. So private void ground spawn. So this is the function that will be called when we want to instantiate the ground. So that's all we need to do, instantiate ground, right? And then let's create a trigger. So on trigger, enter. So we'll set this, but all we want to do, so the easiest way, what we want to do right now is this. So we'll set this collider right now, this on trigger enter collider. So whenever the player enters this collider, this ground spawn function will be called and a ground will be instantiated, right? So let's see what we want to do here. So here we'll add a collider, add a box collider, and we'll edit this collider to basically make it a bit big. And this is somewhere where we would actually want it to spawn the next thing. So this area is fine. So basically when we cross this, a new uh, plane would be spawned, right? So let's attach this script here, ground spawner, and we'll make a prefab of this ground. That's prefabs, and this ground will come here. And this ground we can unpack because there's another script that we'll add to the prefab, which we don't want to add to this one. So we'll unpack this. So this is not associated with the prefab anymore. And now let's set the prefab. In this, we want to add this ground here itself. And in this, we will also add another script. Sorry. So we'll create another script, which will basically, so what we want to do is like once you have this ground, the player reaches here and there should be some way that the new plane that is being spawned should know that the position that it's spawning at is here. So how do we do that? So that is why we'll create a new script, which will basically give a new position to that, the new plane that is being spawned. So We'll create another script. We'll call it new position. In this, all we have to do is create an awake function because we want it to be before anything else happens. And in this awake function, we'll do transform dot position equals to transform dot position, like our current position, and then plus new vector 3 0 comma 0 comma 20. So this 20 is basically the because our plane is at a scale of 2 in x and z direction, and we want to create the new plane in the z direction. So one unit in scale is basically 20 units in the plane. One unit of plane is 20 units in system. Sorry, 10 units. So, and we have basically two units of plane in x and z direction. So if you see, we have 2 cross 2. So basically, we this distance, this place will be 20, and then this will keep happening in every next round. So just save the script and come back to our prefab. We can also add the prefab here, and then in our prefab, we'll add this script, which is the new position script. So I think that's all. Let's see if this works. So we start moving. Oh, we didn't make it a trigger. So like right now, I can't move beyond this point. This is where the collider actually is. Let's see it side by side happening. So I didn't actually make the collider a trigger. So that's why the on trigger function is not working. So this is where I have to make it a trigger. Let's go here and make it a trigger. Save. And then let's see. So you see all first ground is created. So again, mistake that we did is in the prefabs, this is not still set to a trigger. So again, and now it's done. So now basically I can just keep on moving till the endlessly basically, and it will keep on generating more and more the planes for me. So similarly, right, like this, I can generate planes in each directions by manipulating the code a bit, by adding more uh, colliders. That is one thing. I can also keep destroying the planes that I'm leaving behind. Let's say I'm creating a game where I just have to move in one direction. Then all these objects that are being created, eventually there will be hundreds of those if it's a big game. So I can write a code to basically keep deleting the game objects that have been left behind, that are behind. Right. So this is all that I have in this. And if there are any doubts, you can ask, and I'll update this code and everything on GitHub. This in this RAB repository itself that we already have. And now let's create a new project for the new game that we are trying to build. For those of you who have joined late, I'll repeat this. So this is the game that we're trying to build next, which is basically a game where you are controlling a ball, and the rules are that you have a random color when you start, and you can only walk through colors that are similar to you. If you collide with any other color, you die. If you collide with the same color, then you basically increase your score. And this is an endless runner kind of game. There are a lot of things that can be done in this. In this, we'll also learn a few concepts of Skybox and importing the assets and things like that. So yeah, so let's start with this. It's this one, and let's create a new game, and we'll call this one VIPS. We are color runner. So we're calling this one 3D core, nothing here. Just create. Meanwhile, if anyone has any doubts, ask. Why this is taking so long today. Okay, so let's start. So this is again where we start. Let's call it main scene. And this is the scene that we'll work in, we'll create our game in. Before we start, like I said, we'll include some packages in this one. And today we'll talk about some like we can see that this one is a bit beautiful. There's something called a skybox that's in this game. So we'll talk about that and then we'll create the base of the game. So we'll start there. So we'll start by importing packages. If you remember, we go to Windows and then Package Manager, Window Package Manager. So this will open up and I want to see my assets. So this is where basically if you uh, go from asset store and add your assets, this is where it will show up. So we'll show that as well. So one of the packages that I want to include in this one is this package called as Skybox. Here. Yeah, so I can open this. So this is the page that you can search. I'll share this link with you. Later, I can share this link with you. And once you open this, sorry, this will basically give you an option to open in Unity and you can open this and this will add, or one option is you, like if you don't already have this asset in your, like you've not bought the asset in a sense, like if you've not added it to your assets, my assets page, like let's say I open some other asset that is here, whatever random asset, something, asset here. So this is how it will show up, add to my assets. So if you add to my assets, then basically it will show up in your package manager under uh, my assets, right? So in this package manager, you have these options. So you select my assets here. And all I want to do is download. And import. So I select everything. Then this is importing. What is this package all about? see that. So this package that I'm importing is basically a free uh, sh- shaders that are available for Skybox. So we'll learn about what is Skybox in just a bit. So this is an as package that is being provided by a company called or an app creator called Boxophobic, and they're basically giving us a package where we can create animated skyboxes. And some other assets, small assets are also available. This like these trees and stuff that are there, right? So we'll see, and that asset has been downloaded. We want to download one more asset. So like I said, we'll try to create this game for mobile phones. So where we want to use the touch screen. So there's a way that you can code all those things and do that. And we can either talk about that or I'll share specific resources about that. But there is a package that we can use that we will use in this game at least, where we basically, let's see what it has. It's basically a collection of different types of joysticks. Uh, and basically we have a lot of backgrounds and these things and everything is coded. So basically you just drag and drop it in your screen and it will work on touch screens and everything will work properly. So this is a package that we use, and you can obviously look at the code that is making these things, and we'll eventually use this. We'll not use this today or right out, but we'll eventually add this as well. So we'll start by creating for keyboard, like input as keyboard, but we'll eventually use this when we import for mobile phones. So, right, done right. Yeah, so this is also something it's done. Yeah. So I have this and I have this. So two packages are there. In this, I have some demos that are there, which once you upload in download the package, you can see. These are some of the scenes that they've already given, like small scenes, example scenes, like how it can actually look, how your environments can actually look like. And if you want, you can use these things in your environment as well. So, like, we are creating this bland screen, like we are creating a scene where we have created the skybox or an environment, but you can also add trees alongside and things like that, basically making it more beautify your project as you like. So this is a package that you can use for that. And then we have the joystick pack. And in this, we have this is all we use. So there are prefabs of 4 different kinds of joysticks, and we'll use one of these to basically allow the touchscreen movement. Okay, so let's go back to our scene. This is not our scene, main scene. So today, let's talk about Skybox first. So Skybox are a wrapper around your entire scene that shows what the world looks like beyond your geometry. So basically, whatever uh, we have created in the center, like in the game that we're creating, what is present at infinity. So like right now, if I go in my scene, I already have a skybox here. So this is like, if you see at infinity, there's a blue sky and this is, there's a blend here and then there's a gray groundish thing. So this is already a skybox that is there. So how does a skybox actually work? Skybox is basically something which is a cube map. Cube map is basically sides of 6 sides of a cube, which basically defines how it will look from all the different sides. So you can read more about what cube maps are and how Skybox actually works, how it is created, what different shaders and what different materials come together to make a skybox. And if you see, like, I'll share some examples. Some skyboxes can be can be made from very realistic images to make it look like let's say I create a town kind of an environment, and I want the outer of the environment to look like some foresty area. So I can actually create a forest in the skybox. I can't actually go inside that because that is where beyond the scope of my environment or the simulation that I'm creating, but that is something that I can visually see in the environment. Uh, and yeah, basically Skybox is also uh, used to set the lighting of the environment. So that is why when we see, like we'll see just now, how to set the skybox, we'll see that it is under the lighting settings. And that's all. You can read more about it here, but let's just go and actually make the skybox. So window and rendering and lighting. Window, rendering, lighting. This is where you will find most of the lighting settings, which we'll talk about later. But we want to see about the skybox right now. So in this, there are 4 different tabs. You choose the second tab, environment, and you see that there's a default skybox already there. So what I want to do is go here, and then it will give me an option to select from all these skybox, different materials that are already available. And what I want is skybox, this one. I can choose this one or this one. So let's go with the day one for now, but we can change it later and see how that looks as well. Right? So we'll choose this one. So you can see that the environment is looking a bit better, and there's some animations also in this skybox. So you see the clouds are moving in. When we actually play the game, you will see the clouds moving and all those things. So yeah, so this is the setup of the skybox. Uh, I have limited knowledge on how skyboxes are created, but there are tutorials on that as well, and I can share if required. But this is how you use a skybox. There's lots and lots of free skyboxes available on the Unity Asset Store. Like this is some like animated fantasy kind, but there are realistic kinds also available, which will make your environment look day, night, different times of day and things like that. So you can use those when you're creating some realistic type of environment. If you're creating some cartoonish type of environment, there are packages available for those as well. And if you want to learn how to create skybox, you can learn that as well. So now let's move on to actually setting up our environment. So we basically start with ground, and that is going to be a cube. This time we'll make cube ground from a cube, and we'll zero it out first and scale it. So something in the X direction and something in the Z direction. So this is our base. This is where somewhere around where the flare will be. And this is how everything will start. And then we'll create 3 walls in 3 different directions, one left side, right side, and one behind. So the behind wall will be actually used to destroy the things, the objects that are spawning, that are coming towards you. So once they reach this wall, the behind wall, those objects will be destroyed. So let's create those walls, and let's just duplicate this for now. Call it wall left, and I have another scene open for reference. That's why I'm putting these in right away. -8. Currently, things wrong. Oh, might correct in scaling. So scaling would be fun. this is all left, all right. That would be instead of -8, 8. Then we'll have obstacle wall. And for this obstacle wall, the was 0, 5, 7, 5. So that's there. So basically everything's set up. Obviously, I'm just using reference so that it's faster, but you can set it up as you like it. You can make it broader, smaller, larger, depending on whatever you want. Let's create a material for this. Create a new folder. Materials. Create material. Format material. Let's just call it mat, ground mat, and we'll make it grayish, blackish, somewhere in this area. Metallicness, reduce the smoothness, cover a bit. So like just randomly selecting this, whatever, and applying this to ground, the walls. That's all. So this is how it looks. Good enough. And then let's create a empty game object. We call this base for all our things, and we'll put all the things that we created in this. So cool. So we have a base ready, and we need to add some more things. We need to change some more things here. But let's add a player now. First of all, the object, like this is all stuff that we've already done, a lot of the things. So let's just go through it quickly. So one, this will be 0 again. And yeah, that's all. If you want, we can give this player a material, but because we'll be creating it, uh, like we create a script later to randomize this uh, material. So it doesn't really matter much, but still. Make it red and just change this to there. And now let's first create the movement and the camera follow. And after that, we can create more things. This is my reference script. And let's create a scripts folder. Call it player controller. So basically just setting it up like we have already done. So having a public float force equal to 100. We can change this if we want. We have a rigid body. Standard there, and then start just get the rigid body component, then fixed update, fixed update. We want to do, so we want uh, left and right movement, and that's all. And to do that, and because we later create touch screen movement as well, so let's write a comment here. So this is how you write comments with double quotes. I think we've already commented and uncommented a lot of things, but just for reference. So this will be our keyboard movement scripts here, and we'll write if input can be down input dot D. So we want to use left and right. So D, either this or uh, it's right arrow instead of this right arrow. In this case, what we want to do is this add force and add force. So we have this force into time dot delta time, which we generally do into so not this into. So this is the force. Then we define force mode. So what we are doing basically here is we have defined force in the x direction, y direction, z direction, and then our force mode. This we have not talked about yet, but we can. And force mode would be velocity change. And we'll talk a bit later about this. Let's just get this set up. Let's just copy this whole thing. Want to do the same thing. If uh, instead of D, A is pressed, or instead of left arrow, right arrow, left arrow is pressed. And then instead of plus, all I have to do is minus. And that's all. That's all for our player controller script. So let's see if this works. We'll start a rigid body. This, and let's see. So yeah, so it's working for us. Something's on. I think something's wrong. It's working, but it's not perfect. I am not sure why. Check on this. Oh yeah, so basically our uh, collider that we have, we want to create a physics material as well. So basically reduce the friction that is there between the surfaces. That will basically make the movement a bit more smoother. So let me see where that is. Yeah. So we can create it inside material. This is a physics material, and it's basically, where is it? I can't find it. Physics material. Sorry for that. So let's call it zero friction. And basically change everything to 0, 0, multiply, multiply. And let's see if this doesn't work for us. And this is where we add the physics material. So a bit more smooth. And I think we need to add it somewhere else. Do we need to add it? Not really. So still not sure why our movement is not smooth. We have things wrong. Yes. Oh, it's get key. We've done get key down. So there's a difference between get key and get key down. So get key basically returns true while the user holds down the key. And get key down basically when you click and release, that is when get key down returns true. So we want the user to be able to uh, click and hold down to actually move around in the scene and not just click once. So that was the issue here. Sorry about that, but now it should be smooth. Yeah, it is, but our movement is very fast and control using this force. Better. Cool. So we have set this up. Next, let's set up the camera along with this camera follower. So I have a bit of difference uh, how to actually make the camera follower script here. So let me make a new script. So we've already made a camera follower in the last game, but that was basically we set a uh, position in the position already of the camera, and the player was basically following that specific, uh, just the specific camera player. Like the camera was following that specific player using that just an offset. So we'll do something similar, but we'll do it for a specific axis, which is the x-axis, which is the axis that we're moving. So let's call it camera follower. This, what we'll do is basically we need uh, we can do game object or transform because we'll be using transform directly. So we want to get a transform of the player, and this is something that we can make it private as well, but we can just set it here, public int axis. So this is the axis that we'll set as 0 for the x-axis. And then we just need to do an update. In the update function, we will create a new vector 3, which is the new position. And this new position will be equal to the current position of the transform. And in the 0th axis, is equals to transform, sorry, player and just in that axis where the player is. And then transform dot position equals to new position. So if this is clear, what we're doing is basically creating this new vector 3. In this vector 3, we are taking the current position of the camera. And in this position, we're changing the x-axis of the camera to the x-axis of the player, and then just basically reassigning it to the camera. That's all, right? So the camera will be here, this one. And this, we can add this. Axis is 0, player is this one. And just to set it an initial to minus, you can make this a bit, change the rotation to 15. So let's see if this looks good. This looks good, I think. The changing looks a bit more engaging rather than the one that we had previously. So great. So next, what we'll do is basically set the obstacles and then create a script to move those obstacles and create a script to randomize the colors of the obstacles. We try to do something more in the obstacles as well, maybe make it more challenging, increase the speed with time, things like that. So that's where we end today's session. If there are any doubts, you can ask. Otherwise, that's all from my side, and we will have the next session most probably tomorrow. I'll update by tomorrow morning. So we'll either do it tomorrow or day after. But most probably 90% I'm sure we'll do it tomorrow.